Hello everyone, I am going to go over the chapter 4 problem set solutions today. As always, if you have any questions, please email me. I will gladly work with you to figure out a time to go over them, office hours, whatever that needs to be. I know that some of you are still dealing with the aftermath of Hurricane Beryl, and we can email back and forth, just let me know. So the first question says a simple linear regression relates V and S as follows. V equals A plus BS. The dependent variable is going to be on the left-hand side of your equation. It's going to be V. And the explanatory variable is going to be S. The intercept parameter is A. And the slope parameter is B. These are what you're estimating when you look at your regressions. V is equal to A when S is equal to 0. Because the only way that we can get that second term to cancel out, to go away, is if that S is equal to 0. For each 1 unit increase in S, the change in V is B units. The linear regression in problem 1 is estimated using 62 observations on V and S. The least squares estimate of B is negative 21.749, and the standard error is 9.10. Perform a t-test for statistical significance at the 5% level. So first, there are 60 degrees of freedom, and we know that because there's 62 observations minus 2 parameters that we're estimating, which gives us 60 degrees of freedom. The value of the t-statistic is going to be found by dividing the estimate that we're given, which is negative 21.749, by the standard error, which is 9.10. So the value of our t-statistic is negative 2.39. And the critical t-value for the test comes from our t-table, where we're going to look at our 60 degrees of freedom, our 5% level of significance, and we see that it's a 2. So is B hat statistically significant? Yes. And we know this because the absolute value of negative 2.39 is just a positive 2.39, and that's greater than 2. The p-value for the t-statistic is 0.02, which comes from your table. The p-value gives the probability of rejecting the hypothesis that B equals 0 when B is actually truly equal to 0. The confidence level for this test is 95%. The last 3 I've already written out just because I couldn't write fast enough. What does it mean to say that B hat is statistically significant at the 5% level? This is the hypothesis that B equals 0 can be rejected with only a 5% chance of being wrong. What does it mean to say B hat is statistically significant at the 95% level? We're 95% sure that if B is actually 0, the t-statistic will not reject the null. And what's the difference? They give the same information. Next one says we have 28 data points to estimate the following linear relationship. So we know that our intercept is going to be A, and our B hat is going to be represented by the other one. Our slope parameter. What is the equation of the sample regression line? This is going to be F equals 350. minus 14.75 m. Test the intercept and slope estimates for statistical significance at the 1% significance level. In order to do that, we have to figure out our degrees of freedom. Degrees of freedom is going to be 28 minus 2, because we're estimating 2 parameters, which is 26 degrees of freedom. Go to our table. We see that our t-statistic value is 2.779. So then we are going to compare these numbers in the table to our 2.779. And we see that A hat is statistically significant. Because 3.79 is greater than 2.779. Same for B hat. We know that it is also statistically significant. And we know that because we're going to take the absolute value of our negative 3.17 and get a positive 3.17, which is still greater than 2.779. Interpret the p-values. So the p-value for our intercept is 0.0008, which is not a straight line, is 0.08%. And the p-value for our m is 0.0039, which is going to be 0.39%. Which means that there's only a 0.39% chance that B equals 0 with all of the other information. Which 0.39% is very, very small. Test the overall equation for statistical significance at the 5% level. In order to do this, we're going to use this F ratio up here. And you're going to need your F table, which again I just pulled from the internet, at the 5% level. For an F table, you need two different degrees of freedom. The first one is k minus 1. K is the number of parameters that we're estimating, so k minus 1 is just 1, which is highlighted here. And then we have n minus k, which is the same thing that we did for our t-test, which gave us 26, which is over here. So we get that our F table is 4.225. Which is less than our F ratio up here of 47.215. If m equals 25, what is the fitted or predicted value? So we're just going to take the answer we have in A and plug in 25. So we have 350 minus 14.75 times 25, which is going to give us negative 18.75. What fraction of the total variation in F is explained by the regression? For this, you're going to look at your R squared. So 0.6449, which is 64.49% of the variation in F. Question 4 begins the multiple choice section. So it is going to be attached in a separate video just so that the time doesn't get too long.